Right now, somewhere in your body, a craving is forming. Maybe it's not hunger yet. Maybe it's just a smell. Meat on a grill, 2 streets over. Your mouth reacts before your mind does. Saliva, a faint tightening in your stomach. You didn't choose this. It happened to you. This response is old, older than agriculture, older than fire, according to some researchers, older than language itself. In 2010, a team working in the Afar region of Ethiopia found 2 animal bones, a rib and a thigh bone, both from creatures the size of a cow, both covered in thin, parallel grooves. Cut mark, the kind left by a sharp stone dragged across flesh and bone. The bones were dated to 3.4 million years ago. That's the disruption. For decades, the accepted story was that meat eating, real, deliberate, tool-assisted meat eating, began with the genus Homo, with us roughly 2.5 million years ago. These bones broke that timeline by nearly 1 million years, and the creature that left those marks wasn't human. It wasn't even close. It was Australopithecus afarensis, the same species as the famous fossil Lucy, a brain roughly a third the size of yours. No stone tools were found at the site, meaning whatever cut these bones may have been an unmodified rock, picked up and used once, then discarded. If that dating holds, it means the desire sitting in your stomach right now, that pull toward meat, predates your own species. It predates the human brain as we know it. It may be one of the oldest decisions ever made by a creature that would eventually become you. By the end of this, you'll understand that eating meat wasn't a lifestyle choice your ancestors made. It was a biological gamble that rewired the human body, and the trade-off is still written into you today. Let's start at that site in Ethiopia, because the story only gets stranger from here. The location is called Dikika, roughly 6 miles from where Lucy herself was discovered in 1974. The team was led by paleoanthropologist Zirisine Alemseged. When the bones were examined under a microscope, the marks didn't match the wear patterns caused by trampling, sediment, or crocodile teeth, all of which leave distinct, chaotic signatures. These were clean, directional, man-made, or rather hominin-made. But here's where it gets stranger. There was no fire at Dikika, no hearth, no ash, no burn marks on the bone. Whatever meat came off that rib and thigh bone was eaten raw, or close to it. That means the earliest meat-eating moment we have physical evidence for wasn't cooked. It was closer to scavenging than hunting. This matters because scavenging is a dangerous business. Australopithecus afarensis stood about 4 feet tall. On the plains of what is now Ethiopia, 3.4 million years ago, that same carcass would have attracted hyenas, saber-toothed cats, and giant crocodiles. Getting to the meat first, or at all, meant competing with animals built to kill. Some researchers argue this pushes back against the whole scavenging theory. Why would a small, slow-moving primate risk approaching a fresh kill surrounded by predators just for a bite of raw meat? The answer may lie in the brain, or rather, what the brain needed to become. That brings us to Olduvai Gorge, Tanzania, nearly a million years after Dikika. By 2.6 million years ago, something changes. Sharpened stone flakes appear in the archaeological record in large numbers, deliberately struck, not just picked up. This toolkit is called Oldowan, and it belongs to early Homo, possibly Homo habilis, a species with a brain about 50% larger than Lucy's. With these tools, meat access changes completely. Cut marks on animal bones from this period appear underneath tooth marks left by other predators, meaning early humans were now getting there first, or fighting for the carcass, not just picking at leftovers. This is where anthropologist Richard Wrangham enters the story. Wrangham didn't focus on the meat itself, he focused on what came next, cooking. His theory, published in the early 2000s, argues that cooked food, not raw meat, is what truly launched the growth of the human brain. Cooking breaks down muscle fiber and connective tissue before it ever reaches your stomach. It does part of your digestion for you externally over a fire. The math is specific. A raw diet of meat and plants requires enormous amounts of chewing and gut energy to extract calories. Chimpanzees today spend nearly 6 hours a day chewing. Modern humans spend about an hour. Cooking didn't just make meat taste different, it appears to have freed up energy that Wrangham argues was rerouted over hundreds of thousands of years into a rapidly expanding brain. Except there was a problem. The oldest confirmed evidence of controlled fire doesn't line up with the timeline Wrangham needs. The strongest, most widely accepted early fire evidence comes from Wonderwerk Cave in South Africa, dated to roughly 1 million years ago, burned bone and ash sealed deep inside the cave, far from any surface fire that could have blown in. That's hundreds of thousands of years after Homo erectus brains had already begun expanding. So if cooking didn't start the process, something else did. And the answer may be uglier and closer to the bone than anyone expected. Go back to raw meat itself, not cooked, not processed, just torn flesh, eaten fresh from a carcass on the savannah. Even raw meat is a radically different food than the leaves, roots, and fibrous plants that made made up most of an early hominin's diet. Gram for gram, meat delivers roughly twice the calories of most plant foods and far more protein and fat. A 2011 analysis by primatologist Jessica Rothman, studying wild chimpanzee diets in Uganda, found that meat, even eaten rarely in small amounts, supplied a disproportionate share of their fat and protein intake compared to time spent eating it. That means the shift didn't require fire. It required frequency. A creature that once ate meat by accident, opportunistically off a lion's leftovers, slowly became a creature that sought it out. By 1.8 million years ago, Homo erectus appears in the fossil record with a brain nearly double the size of Lucy's species, and a body built differently too. Longer legs, a narrower ribcage, a body built for endurance, not just for climbing. Some researchers, including anthropologist Daniel Lieberman at Harvard, argue this build points to persistence hunting, chasing an animal for hours in open heat until it collapses from exhaustion, since humans cool by sweating, and most prey, animals do not. If that's true, meat didn't just feed the brain. It reshaped the entire skeleton around the pursuit of it. Here is what that means for you. The craving you felt at the start of this, that automatic pull toward the smell of meat, isn't a modern invention. It isn't marketing or culture or a habit picked up in childhood. It may be a signal inherited from a 4-foot-tall creature standing over a carcass 3.4 million years ago, holding a sharp rock, deciding whether the risk was worth it. Every time that decision paid off, across millions of years and thousands of generations, it left a small trait: a slightly larger brain, a slightly longer leg, a slightly stronger stomach for handling raw protein and fat. You are the accumulation of that decision, repeated successfully enough times that it became permanent. The meal in front of you tonight will end in minutes. The decision behind it took 3.5 million years to make.